Today we are going to learn about how to soften the water by ion exchange process. Before going to learn about the softening of water, what are the objectives of this particular lecture? We are going to learn about how to soften the water, how to remove all the ions which are present in the water. Otherwise, this process we can call it as a deionization of water. How to remove minerals from water, or otherwise this process is also called demineralization of water. So first, what is softening of water? Whenever calcium, magnesium impurities are present in a water, we can call it as a hot water. So removal of calcium, magnesium ions from water to make it soften is called softening of water. This can be done by the various process like lime soda process, geolite process, ion exchange process. Today we are going to learn about this ion exchange process in this particular day. What is the ion exchange resin process? So here you have to understand two important words. What is an ion exchange and what is the resin? The first, what is the resin? So resin is a polymer which is obtained by combination of various monomers. So here the resin is a copolymer. It is a copolymer of vinyl benzene. So this is what the structure is. This is the vinyl group and this is benzene. This is vinyl benzene, divinyl benzene. So here two vinyl groups are there connected with a benzene. So it is obtained by the combination of vinyl benzene and divinyl benzene. So how this repeated unit will be formed here? Just write vinyl benzene first and add the extensions and put the vinyl benzenes. So this is the repeated unit of the resin. It is a hydrocarbon, but when we just want to exchange ions, it needs polarity. So what we have to do the polarity, we have to introduce the polar groups here in this particular resin. This introduction of polar groups, we normally call it as a functionalization. We have to functionalize this hydrocarbon resin with the different groups. So, what are the groups that we have to do? So, if the resin is functionalized with the polar groups, then the functional groups attached to the polymer chains are capable of exchanging ions present in water. So, there are two groups that we normally introduce here to exchange cations, to exchange anions. So, to exchange cations, what we normally need is active H plus containing groups, so that we can call it as a acidic groups. Acidic groups like COOH, SO3H are introduced into the hydrocarbon resin. Then we can call it as it is a cation exchange resin. This H plus can capable of exchange of calcium and magnesium ions. Or otherwise, if the hydrocarbon resin is functionalized with quaternary ammonium or phosphonium or tertiary sulfonium bases, then we can call it as a anionic exchange resin. This OH minus is capable to exchange calcium and sulfate ions. So this is a cationic exchange resin and this is an anionic exchange resin. If we are functionalized with acidic groups, it is a cationic exchange resin. If we are functionalized with ammonium bases, then we can call it as an anionic exchange resin. So this is schematically what is an exchange resin. These are the columns which are fitted with cationic exchange resin and anionic exchange resin. So we are connected directly to the tap. So once a tap water is passed first through the cationic exchange resin, then to the anionic exchange resin, and water is free from calcium and magnesium ions. How we can achieve this? So demineralization process, how we can achieve this? So the hot water, the tap water, if you are just passing for identification, we just make a mark here. Hot water is passing, then what will happen? So the red mark here it is indicated as a calcium, and this brown mark indicated as a magnesium, blue mark indicated with a chloride minus chloride ion, and this brown mark indicated as a sulfate ion. So what will happen when we are passing the calcium, magnesium ions and chloride and sulfate ions through the cationic exchanger? As the name indicates, it is a cation. So only the positive ions will be exchanged. So these will too convert it into H plus ions. So in the form of an equation, we can see that this is the resin. Calcium is passing through this particular resin. Calcium is exchanged with the H plus ions present in the resin. So that the H plus ions will come out. And magnesium also the same. So these two are the H plus ions. When once passed through the anionic exchange resin, anions will be exchanged. There is no change in the cations. We can see that. The anions are converted into OH minus ions. The yellow mark indicates that they are the OH minus ions. Here 2Cl minus reacts with the anionic exchange resin. It will be exchanged, we will get the OH minus ions. What will happen? The H plus and OH minus will form as a H2O. So this is what will happen. Ultimately, what we normally get? It is free from ions, so soft water that we will get. There is the water is free from calcium and magnesium ions, so that's why we will get a soft water. After some particular time, what will happen? These exchange resins are completely filled with calcium magnesium ions. So no more exchange will take place when there is no H plus ions are there in the particular resin. If it is filled only with the calcium magnesium ions, it cannot exchange further. Then we can call it as a exhausted ionic exchanger. What we can do? We can regenerate back. How we can regenerate? By just passing more acidic active H plus ion containing solutions, or by adding OH minus active solutions. So that's why anionic exchange resin can be regenerated with NaOH solution, and cationic exchange resin can be regenerated with H2SO4 solution. So these are the reactions. So the cation exchange resin filled with calcium can be regenerated by passing the H plus ions containing H2SO4. Then what will happen? We will get back H2O. So it is the actual resin, hydrogen resin, the acidic resin, and RCl. When we are passing with the OH minus ions, then we normally get the anionic exchange resin back. So we can regenerate back ion exchange resins with H2SO4 and NaOH. What are the advantages? So we just normally learned that there are three processes, and the lime soda process, geoloid process, and ion exchange process. Ion exchange process has some advantages compared to the other two. The first advantage is the equipment is compact. We can just place it any corner of the room, and layman, any person which is not having much idea about this particular instrument also can operate this particular process. No sludges will be formed. As far as line soda process, we can see that there are more sludges will be formed, so no sludges will be formed. Acidic and highly alkaline water also can be treated, but as far as the GLA process concerned, we cannot treat the acidic water or highly alkaline water, but we can do with this process. And both cations and anions present in the water can be removed, hence it is completely called deionized or demineralized water. But the residual hardness, when we just observed, the hardness still left in this particular water is 2 ppm. So the disadvantage is installation and maintenance is very costly, and the turbidity water, the water is more turbid and its turbidity is more than 10 ppm, we cannot treat by using this ion exchange process. Thank you very much.